This is another implication of the definition of algebra of subsets of a certain set. And we're able to establish already by definition that a certain algebra follows the condition of being closed under finite union and closed under complementation. In the previous video, we're also able to establish the possibility of it being closed under finite intersection as one of the implications. So you might want to review those two videos, and we are going to proceed now in showing that this is true. Now, for the purpose of discussion, let me rewrite here the definition of the algebra of sets. Okay, so we have here, let X be non-empty, and let's say there is a certain set, let's say script A, be a subset of the power set of your set X, where your script A is also non-empty. We can say that script A is an algebra, okay, this is its definition, or algebra of subsets, or in this case of X, if it satisfies the following conditions. Okay, A1 or the first condition is that if a certain two sets A and B, this is B, be element of your script A, this implies that their union is also an element of script A. As mentioned, this is closed under finite unions. The second condition is if your set A, since A is script A is not empty, if it's an element of your script A, this implies that its complement is also an element of script A. So these two are already given by our definition. This should satisfy the consideration of algebra if they are both satisfied as well. But here, what we're going to show that the empty set and the set X itself is an element, or are both of them are elements of your script A. So first, let us have here our proof. So we of course let script A be an algebra. That would mean if this is an algebra, and any of these two or both of these two conditions may be used in our definition, or our proof, in showing that both the empty set and the set itself, set X, are elements of your script A or your algebra. Okay, so let's start with this. Of course, since script A is an algebra, of course it's non-empty, so we can pick any. We can pick any element. Okay, so in this case we can say let me rewrite this, make it better. Let A be an element of script A. Okay, it's okay because again, script A being an algebra, so it's not empty, you can pick any. Okay, so with that, let us use one of the conditions above that already being satisfied, being script A already identified as an algebra. So by, let's say, A2, since A is an element of script A, it would mean that its complement is also an element of script A. Okay, this is by A2, so we can say that this is true. Now, let's try to combine A and its intersection. So we can now say that A, the union of A and A intersection by A1. Okay, because if we have two different sets, in this case A and A complement being elements of script A, then according to A1, their union is also an element of script A. But what is this, by the way? When you combine a certain set and its complement, given that, okay, our script A is a algebra of the subsets of set X. Okay, so when we try to combine them, okay, when we try to combine or get the union of A and its complement, it's equivalent to the set itself, set X. Okay? So set X is an element of your script A, and this is the first item we're trying to prove here. So we can say here, thus, so that we are trying to show some probably generally a conclusion on our statement. So we have this already identified. Again, as mentioned, when you try to combine A and its complement, given that these are just elements of your script A, which is a subset of the power set of X, or better yet, script A is already an algebra of a subset of X. That means their combination is X itself. Again, it's already done. Now let's look into the concept on whether the empty set is already an element of script A. Now, since this is already okay by A2 again, okay, we can say that the complement of X is also an element of script A. Because again, if A is an element of script A, its complement is also an element of script A. And what is actually, okay, what is actually the complement of your X? Okay? What is the complement of your X? Being X is the set itself here, okay, being non-empty. So the complement of X being the set itself is equal to the empty set. And since let me rewrite it here, okay, so if this is an element of A, meaning its complement, and this is true because of this, right? So its complement is just equal to the empty set. Let's say here then, sorry, let's make here then X, the complement of X, which is the empty set, is also an element of script A. So we are done showing both of these two being element of script A. And what does this tell us? It's called an implication of a definition. Yes, in the previous video, we were able to say that the finite intersection is also an element of script A. Now, this tells us that empty set and the set itself is an element of script A, being an algebra. The implication here is whatever, if you are to write algebra of subsets of a certain set, let's say X here, the X itself and the empty set should always be an element of that algebra. Because if they are not around, then that means, because of this implication, whatever set you're writing, it's not an algebra of another set. So the empty set and the set itself should be contained by whatever algebra you're writing there, aside from, of course, following the concept of being close under finite union and close under complementation given by these two. The empty set and the set itself should appear in your set to be called an algebra. We will have examples for this for verification in the next videos. Thank you very much for watching.